We're given the graph of g of x, sketch the graph of its inverse on the same grid. So you can draw a dotted line at y equals x. And one, you can flip it over that line. The other thing that you can do to be more accurate, because sometimes eyeballing and trying to flip things over, is take some of the points that you have, like negative 4, comma 4. We've also got 1, comma 3, and 3, comma 2. Take those points and switch the x and the y coordinates. Well, what happens to negative 4, comma 4? It's going to be at 4, comma negative 4. 1, comma 3 becomes 3, comma 1. 3, comma 2 becomes 2, comma 3. And you can see that I chose not to label one point. Well, I should probably do that as well. We had the point negative 1, negative 1. If you switch the x and the y coordinates on that one, it's going to stay the same. Now, connecting the dots can sometimes be hard, because we've got 4 dots there, and you possibly could really screw this up by connecting them in the wrong way. Okay? Again, this is where you can think about it reflecting over. This point joins to this point, this one to this one, this one to this one. And the other key characteristic of this when we join our points, and this is easier when it's straight lines because it happens naturally, but we have to be careful that this should be fairly accurate. Any points on that line y equals x are going to stay the same. So the two graphs will always intersect where the y equals x. Because if you had the same x and y coordinate and then you switch them, they would still be the same. So we've sketched the inverse on the same grid. Part B, is the inverse a function? So for part B, just a little review from previous years. How could you tell if a graph was a function? Do you remember doing that? No? When I write it, does this, if it passes the vertical line test? How many people have heard of the vertical line test? Few. So maybe not everybody's seen this. That's okay. What the vertical line test says is draw a vertical line. There we go. If, as you're moving that vertical line across your graph, check the red graph first. How many times does the vertical line hit the red graph as it goes? Only once. There's never a place where I hit the red line more than once. The vertical line test says if that vertical line always hits it only once, your graph is a function. If at any point that you're sliding that vertical line across, if it hits your graph more than once, it is no longer a function. So for example, in the blue one, right there, I mean there's lots of places, right there, it hits 3 times. If it hits more than once, the blue graph is not a function. So in explanation, we could say no, it doesn't pass the vertical line test. And what that means is some x values have more than one y value. That's really what makes something not a function. I mean, if we use the English language, sometimes you say something functions, right? You would say your calculator functions well if when you do 4 plus 4, you get 8. It wouldn't function very well if the next time you did 4 plus 4, it'd say 7. And you're like, what? And 4 plus 4, now it's 8. Okay, good. 4 plus 4, now 7. You would say, this isn't functioning right. Something's wrong. So in functions, when you put something in, you always want to get the same result. X squared is a function. What do you get when you square 5? 25. If you did it again, would you get something different? No, you'd always get 25, right? And so we have certain things are functions if they always give the same number. So we can test that with the vertical line test. Now, when we state the domain and range for both the inverse and, oops, I'll go blue. Part C, we'll do the domain and range for both the original function and the inverse. So the original one was in red. Our domain of our original one, if we look at the graph at what the smallest x value is, the smallest x value was -4. And if we look at our original graph at what the largest x value was, it was 3. So x is between -4 and 3. This is an interval notation. I'll do interval notation for the range as well. Our smallest y value on our original function was -1. Our largest y value on our original function was 4. Now, to find the domain and the range of your inverse, which we've got up here in blue, again, we could look at the graph because we've drawn it. Can you see that now that your smallest x value on the blue graph is at -1? And your largest x value on your blue graph is 4. But if we didn't see the graph, we could do this as well. So if I go back to here where I can't see the graph, how do I know that my range is -4 to 3? We switch the x and y values. So our original x values, when they get switched, they become our y values. And our original y values, they got switched, they became our x values. So on your next page, I think they even have like a shaded box where they say domain and range of a function and its inverse. They're just saying that those things have been switched. So try questions 4 and 9.